Hi friends, welcome back to part 2 of data analysis of health insurance data using Python. In the previous video, we have seen how to use Google Colab and explore the Kaggle website. If you are new in this tutorial series, I would advise you to watch the part 1 and then come back to this video. The link for the previous part of this tutorial is mentioned in the description below. Today, in this tutorial, we'll have a look at the columns in detail and touch upon exploratory data analysis. To get the column names of the data frame, we will use .column option. In this data set, we see there are 7 columns in total. Let's have a look at the number of rows and columns in the data frame. For this, .shift command becomes handy. In reference to this dataset, we see that there are 1338 rows and 7 columns. Let's look a little more in detail about the data frame. .info helps us to get the column level information like number of nominal values and data types. This type of summarized structure of the data frame helps us have a quick idea without much of an effort. Now let's have a summarized view at the data level, like what is the mean, what is the standard deviation of the data in each of the columns. .describe function helps us to get this information of all the numerical columns. Python pandas package is smart enough to understand the data types of each of the variables. However, in few cases, we might need to explicitly change the data types, like the case for children column here. Children column is basically a categorical column. However, the pandas have treated it as a numerical column. We can make use of .astype function to change the data type of the columns. We will discuss this in future videos. After having a brief idea about the columns and their structure, let's jump to exploratory data analysis and data cleaning. As part of a data analyst job, we spend maximum time in doing this task. Unless we get the data right, we cannot expect good results from a predictive model. Data cleaning is all about detecting anomalies in the data and performing operations to treat them well. As they say, if we input junk to the model, we'll get the junk output. So we should take care of transforming the data right and also have a check on the quality of data. So here we will find out the null values, if any, in each of the column. For that we will use .null function as well as sum to get an aggregated result. We see in this data set there are no null values in the columns. Now let's visualize all the columns one by one. Here we take the numerical columns first and then we will have a look at the categorical columns. Plot in Python can be created using matplotlib or seaborn packages. In this tutorial, we have made use of seaborn packages the most. Histogram is a good way to visualize the distribution of numerical data. In this plot, we will see that age is skewed towards the right and it do not follow a normal distribution. But this is not case with BMI column. The BMI on the other hand is almost normally distributed. Now let's have a look at the box plot, which will help us to find out if there are some outliers in the numerical columns. Outlier friends are abnormally high or low values in the dataset which doesn't fall in the normal range. Technically, the outlier values lies beyond Q3 plus 1.5 times IQR on the higher side and Q1 minus 1.5 times IQR on the lower side. Q1 is nothing but your 25th percentile value and Q3 is nothing but your 75th percentile value. In this plot, we see that BMI column has outliers but there are no outliers for the age column. Now, to get the specific values of the outlier, we'll make the use of boxplot underscore stats function. With this function, we will parse the BMI column of the health insurance data frame. The result of this column will be a list of dictionary with the flyer as one of the key. The value of the flyer gives us the outliers present in the BMI column. You can see the exact value returned by this print statement here. Now let's have a look at percentage of outlier in the entire dataset. It comes out to be 0.67%, which is almost negligible, and hence we can take a call of dropping these rows. Based on the EDA that we performed on numerical data, we decide to convert the values in the age column into age brackets, namely young, mid-age, or old age. This is what this section of code helps you do. Now we will drop the rows which have the outlier values in BMI column and redo the box plot. You can see in the diagram below. So friends, in this tutorial today, we have seen how to approach the data cleaning and EDA. I prefer to consider the analysis of numerical variables and categorical variables separately. So, we will be discussing the same for categorical variables in another part of the tutorial series. If you like what you see here, help us by subscribing to this channel and like the video so that we can come up with some better stuffs next time. See you next time. Happy learning.